Okay. Oh, you guys can't see. Why can you not see it? There we go. Okay. All right. So before we start doing these problems, for those of you here in the class and for those who are watching this video later on, I just want to emphasize that this review is not enough. This should not be your only source of studying for this exam, because this chapter we cover many different topics, not all of which is included in this review. Okay? For example, remember we did double time and half time. We did that in our last lesson. There's not an example like that in here. So my recommendation would be to go back to your lesson notes, go back to your homework for examples such as which. Or if you want, come during office hours or the optional out-of-class review, and maybe I could try to make up a problem, to practice such as that. Or similarly, I know some people were coming to my office hours asking with help about the word problems involving inequalities, right? How to set it up, how to solve it. I do not recall, but I don't think there's a problem like that in this study review. But it doesn't mean you don't need to know it. It's just there's a lot of topics that are not all included in this review. So in addition to this review, you should be referencing and studying from our lesson notes and your homework. There are topics on the exam that are not included on this review. Everyone understand?
That's good to know.
Okay. Okay.
There are topics on the test that are not in this review.
So again, and that's just because there's so many topics we did, and it's just not all included on the review. But if you come during office hours or the optional exam study, if there's any sort of problem you want to practice more of, we can do so. Okay, so let's jump to it. Number 1, part A, solve the equations. Let's see how y'all did. So part A, negative 4x plus 7 equals 15. We want to solve for x. You want to get x alone. So let's first subtract 7 from both sides of the equation. So that way those 7's cancel. We are left with negative 4x equals 8. Next, to get x alone, we can divide both sides by the negative 4. That way on the left-hand side, the negative 4's cancel. You are left with x equals 8 divided by negative 4 is negative 2. And of course, feel free to use your calculators for any assistance you may need. Any questions there? All right, part B. Part B is a little bit trickier. As you can see, there is some simplifying we can do before we begin to solve. So I'm first going to just focus on the left-hand side of the equation, okay, just the left-hand side, and I'm going to simplify it. So I'm going to simplify it by distributing the negative sign. Negative times 3x is negative 3x. Negative times the positive 4 becomes a minus 4. So I have now simplified the left-hand side as much as possible. Going to bring down the equal sign. Next, let's simplify the right-hand side as much as possible. Okay, the right-hand side can be simplified as well. And I'm going to start off by distributing the 6. Take the 6 and multiply it to each term inside of the parentheses. 6 times 2x is 12x. 6 times negative 7 is the minus 42. And then that plus 8 comes down. Before you begin to solve, stop and see if you can simplify this any further, the right-hand side, which you can. You can simplify the right-hand side further by combining these values here, the constants at the end. So everything else just comes down. The minus 3x comes down, the minus 4 comes down, equals 12x. Everything else just came down. And let's simplify by combining those like terms. Negative 42 plus 8. Negative 42 plus 8 is negative 34. Now we are done simplifying. We've simplified the left-hand side as much as possible, and we've simplified the right-hand side as much as possible. So now we can begin to solve for x. Now we can begin to do things to both sides of the equations to get our x alone. First, get your x to a side of the equation. It doesn't matter whether you get to the left or to the right, up to you. Your work along the way may look a little bit different than me, but the end result will be the same, just depending on which side you get your x on. I choose to get rid of this negative 3x in the front by adding 3x to both sides of the equation. So that's what I'm choosing to do. You may have chosen to do something else, and that's okay. I'm going to get rid of these 3x's. They cancel. So I'm left with negative 4 equals 12x plus 3x is 15x, and then bring down the minus 34. That way my x is just on a single side. I got my x's on the right-hand side. Now, to get x alone, I first need to add 34 to both sides of the equation. That way on the right-hand side, those 34's cancel. Negative 4 plus 34 is 30 equals the 15x comes down. Lastly, to get x alone, we divide both sides by 15. So the 15's cancel on the right-hand side. 30 divided by 15 is 2, so you're left with 2 equals x. Any questions there? All right, part C. Again, the first thing I'm going to do is simplify it if possible, and it looks like we can here. On the left-hand side, I'm going to simplify by distributing the negative. So distributing the negative sign, I get negative 2x. Negative times 2x is negative 2x. Negative times the positive 3, that becomes a minus 3. The equal sign comes down, and that's all I could do on the left-hand side. I cannot simplify that any further. Now let me focus on the right-hand side. Can the right-hand side be simplified? And yes, it can. So we're going to first distribute the 2 to each term inside of the parentheses. 2 times x is 2x. 2 times 2 is 4. And that plus 3x comes down. Check to see if you could simplify any further, which we can. On the right-hand side, we can combine our like terms. Our like terms being the 2x and the 3x, right? 2x and 3x are like terms, so those two values can be combined. So the minus 2x, the minus 3 comes down, equals 2x plus 3x is 5x, and then bring down the plus 4. Just double check, make sure the left-hand side is simplified. It is. My right-hand side is also simplified. We can now begin to solve. We can begin to do things to both sides of the equation. So personally, again, I like to work with my x's first. It does not matter whether you get x's to your left or to the right. It's up to you. Just to change it up a bit, last time I got my x's to the right-hand side. So this time I'm going to move my x's to the left-hand side because why not? Okay? So do whatever your heart desires. So to get my x's to the left-hand side, I need to get rid of it on the right. On my right-hand side, I currently have a 5x. That means I need to subtract 5x from both sides of the equation for the 5x's to cancel. What are we left with? Negative 2x minus 5x is negative 7x.
So I would automatically think that, like, when I'm at that step, I think it's time for me to divide now. And it's not.
No, not yet. Because we still, you mean
The 5.
at this point here?
Yeah.
The only time you should be dividing is when all you have left is your x term. But if you have
Okay.
pluses and minuses going on with additional terms still, you got to solve that portion first.
Okay.
Yeah. So the -3 comes down, the equal sign comes down, the 4 comes down. Okay. Still continuing to get x alone, we now add 3 to both sides of the equation. That way the 3's cancel. You're left with -7x equals 4 plus 3 is 7. And lastly, to get x alone, divide both sides by not just 7, but -7. The negatives need to cancel out as well. You're left with x equals 7 divided by -7 is -1. Any questions here, guys? All right, let's continue. Number 2. Peter Gibbons borrowed money from his friend Michael Bolton in January and pays him back the same amount each month. 4 months after January, he owes $300. And 8 months after January, he owes $120. Find the linear function that models the amount owed, y, after a number of months, x. Okay, so overall, what are we finding here? We want to find the linear function. Find the linear function. Which, what does that mean? That means we need to find our equation y equals mx plus b. That's our goal. We need to find y equals mx plus b. Of which, what do we need? We need to find m and we need to find b. We need to find m and we need to find b. In order to do so, we need to have 2 points to work with. Okay, we need to have 2 points to work with. And what are those points? Well, we're already told, well, let me back up. We know that points are in the form of x comma y, right? Points are of the form x comma y. And it tells us within the problem, x is the number of months and y is the amount of money owed, right? So let's write our 2 points then. X is the number of months. In this case, we're first told that after 4 months, he owed $300. We're also told that after 8 months, he owes $120. Typically, in general, time, if you are given a measure of time, time is like almost always going to be your x value. Okay, time is almost always your x value. And then whatever else is the y value. Any questions so far?
So many, but go ahead.
Okay. If you look to your formula sheet, there is a formula that tells us how to find m. Remember, m is one of the values we need to find. Should be at the top of your formula sheet, right? It tells you to calculate m. M is equal to y2 minus y1 over x2 minus x1.
Okay.
So, if it's helpful for you, feel free to label your points. I'm going to call this my x1, y1, and my x2, y2. And so taking those values, plug it into the formula. And we get 120 minus 300 over 8 minus 4. And then feel free to use your calculators to help you simplify this. This becomes negative 180 over 4, which simplifies to negative 45. So awesome, sweet. We have found one of the two things we need. We needed to find the slope m, which we now have. Let's go ahead and substitute that into our equation. So we have y equals negative 45x plus b, where all we have left to find is b. Okay, all we have left to find is b. To find b, plug in one of your points. So either use the first point, plugging in 4 for x and 300 in for y, or you could use the second point, plugging in 8 for x and 120 in for y. It does not matter which point you pick. Your work along the way might look different, but the answer in the end will be the same. So do you guys have a preference? Do you want to work with the first point or the second point? First? Okay. So using the first point, plug in 4 for x and 300 in for y. So you get 300 equals negative 45 times 4 plus b.
Oh, I thought that was B.
No, we need to solve for b. We don't know what b is.
Okay, so,
I'm going to carry this over here because I'm running out of space.
because that's Y.
Okay. So 300 equals negative 45 times 4. So I'm going to simplify this piece right here. Negative 45 times 4 is negative 180. And then you still have the plus b. To get b alone, because remember, that's our goal. Our goal is to solve for b. To get b alone, I got to get rid of this negative 180, and we do so by adding 180 to both sides of the equation. So that way the 180s cancel. You're left with 480 equals b. So sweet. I have now found my b. I found my m, the slope, and I found b, the y-intercept. So now we're going to rewrite, our linear function, our linear equation with the m and the b that we have found. So overall, y equals negative 45x plus 480. And that is the final answer. Any questions?
Which unit was that?
This was, oh gosh, 10.1, I want to say, or 10.2. It was definitely the earlier sections of chapter 10. If you recall in whatever section that was in, 10.1 or 10.2, we did problems like this using the points here, but we also did this same thing where you weren't given your XY points within a word problem, but instead you were given a graph. Do you remember that? You're given a graph. So you want to be comfortable, in addition to finding linear equations given a word problem such as this, you want to be comfortable finding linear equations given a graph. Feel back to reference to our lessons and our homework. I know for a fact they were in there. Okay? Like 10.1 or 10.2, I can't. It was early. Let me see if I can find it real quick, if it doesn't take me too long to find it. Yeah, like the first 3 sections was all about linear equations. Oh yeah, in 10.1. In 10.1, we found a linear equation using a graph. Okay, so you want to be comfortable with both options, all right? Any other questions? All right, let's continue. Number 3. Jesse needs to sell his records. They are stored in a unit that costs $120 in rent each month, and it costs him $6.50 to ship each one that sells. When he sells the records, he charges $14 for each of them. Write the cost function for selling records and the revenue function for selling records, using X to stand for the number of records. Use your functions to find out how many records he needs to sell to break even in a single month. There's multiple parts going on here, okay? Let's do one thing at a time. Let's first, it's not letting me choose it. There we go. Let's first write the cost function. Okay, let's first write the cost function. This is how much it costs Jesse to have these records and be trying to sell them. So tell me, how much does it cost Jesse no matter what in rent for the storage unit? $120. Right? No matter what, even if he sells 0 records that month, he still has to pay the $120, right? Additionally, how much does it cost him when he sells the record? $6.50 because he has to ship it to the purchaser. So he's paying $6.50 per record. All of that is cost, all right? So I'm going to do cost equals, right? We use C for cost. So cost equals the $120 he for sure has to pay in rent plus the $6.50 per record it costs to ship. Does that make sense? That setup. Okay. So that was part of it. It also wants us to write the revenue function when he sells the records. So how much revenue does he make when he sells the records? How much does he make when he sells the record? It's $14, right? When he sells the records, he charges $14 each. So how do you write that as a revenue function? R equals what? 14x. Exactly. So figure out how much it's costing him to essentially run this like miniature business, right? And how much revenue he's getting. So that's part of the question. Now we're at the last part. Use your functions, our functions being these 2 equations we just came up with. Use these functions to find out how many records he needs to sell to break even. Remind me, what does it mean to break even? I believe it's even on your formula sheet. Say it again? Yeah, when you break even, that's when your cost equals your revenue. Right? Because you're not making money, you're not losing money. Your cost equals the revenue. That's break even. So when you want to break even, that means that your cost equals your revenue. Or revenue equals cost. It really doesn't matter which direction. So that's telling me to take my cost equation and set it equal to my revenue. So 120 plus 6.50x, that was my cost. Set that equal to the revenue. Set that equal to 14x. We're not done, but are there any questions on this setup? Yes.
Why can't 120 be X? That's something not
So we're only doing this for a single month, Okay, and so we know for a single month it's $120 flat, right? It's not $120 maybe plus some fees, or depending on how many hours you're there. Like, there's nothing else. Like, it's just $120 flat versus the 6.50. That 650 is per record that he sells, where X represents the number of records he sells, right? Because if he only sells 0 records, it's gone. If he sells 1 record, then you'll do 1 times 650. If he sells 20 records, you'll do 20 times 650. Okay? But the rent, the $120 in rent, there's no dependency there on how many records he sells, right? Whether he sells 0 records or 1,000,000 records, he's paying $120 flat.
So in another problem, let's say I get 120, it would just stay like by itself, no variable or anything for the initial cost.
Well, this one also didn't give the variable here for the 650, right? It didn't explicitly say which one the X goes to. You have to put it in the context of the problem and identify which value is the stagnant value that's not going to change regardless. And then you have to identify the value that's dependent upon something else. In this case, the value that's dependent is the shipping cost, because the shipping is dependent on how many records he sells. Okay. Any other questions so far before we continue to solve? Okay. So solving, you want to get x's to one side of the equation. It does not matter which, up to you. I am going to subtract the 650x from both sides of the equation. So that way on the left-hand side, the 650x's cancel. We are left with 120 equals 14x minus 650x is 7.50x. Continuing to get x alone, divide both sides by the 750. And as usual, feel free to use your calculators. 100, that way, and also on the left hand, blah, blah, blah. On the right-hand side, the 750s cancel. On the left-hand side, 120 divided by 750 is 16. Equals x. So this means Jesse needs to sell 16 records to break even. To get a net zero, okay? To get net zero, he needs to sell 16 records. If he sells less than 16 records, he's losing money. If he sells more than 16 records, he's making money. But if he sells exactly 16 records, net zero. Not losing, not gaining. Any questions? Okay. Number 14. Milton has a job filing TPS reports in the basement of Initech. He can file 15 reports in 3 hours. Part A. Use a proportion model to create a function that gives the number of reports filed n after t hours. Part B, find the constant of proportionality and explain what it means in the context of the situation. Part C, assuming he can work consistently with no break, how many reports can he file in 8 hours? Okay, so one thing at a time. Part A. Sorry, I feel like I'm about to sneeze. Okay. Part A, use a proportion model to create a function, like create a function, write a function that gives the number of reports filed n after t hours. So that's going to be y equals mx plus b. Remind me though, specifically for proportional models, which this says it says use a proportional model. Specifically for proportional models, we know right away that b is what? Always. 0. You need to know that, guys. You need to know that automatically for proportional models, b is 0. So really we just have y equals mx. Of which, what do we need to find? We need to find m. Okay? Which, recall, how do we do so for a proportional model? For a proportional model, m equals y divided by x. Y divided by x. Which we are given y and we are given x. In this case, what's our x, what's our y?
15 divided by 3.
Yeah, exactly. So 3 hours, that's our x. Remember, almost always x is time. Okay, if you're given a time variable, that's your x. Okay, so x, or we could also use t, because they said to use t hours, you know. And then that means the number of reports filed, or 15 reports, is your y, or n. This is the same thing as n over t. Either way, we're taking 15 divided by 3, which is 5. So we have y equals 5x, but it does specifically want us to use n for the reports filed and then t for the hours. So just replace it accordingly. N is the number of reports filed equals 5 times the time. And that is it for part A. So this here is the final answer for part A. Yes?
Will we get that wrong on the test if we don't change the image?
I'd like to use n and t. Yeah, it wouldn't be fully correct. If specific variables are provided, use those specific variables. Any other questions? Part B. Find the constant of proportionality and explain what it means in the context of the situation. So tell me, what piece of this is the constant of proportionality? Is it the n, is it the 5, or is it the t? It's the 5, right? It's the 5. So m equals 5 is the constant of proportionality. And then what does it mean in the context of the problem? This tells us that Milton can file 5 reports per hour, right? He can file 5 reports per hour, which makes sense. If he can file 15 reports in 3 hours, then how many can he do in a single hour? That's equivalent to 5 reports in a single hour, or 5 reports per hour. Part C. Assuming he can work consistently with no break, how many reports can he file in 8 hours? Well, we have an equation now to determine that. We are going to use our equation, n equals 5t. And where do I plug in the 8? Do I plug it in for n, or do I plug it in for t? For t, because it's 8 hours, and I want to know how many reports he can file. So that's n equals 5 times 8, plugging in 8 for t, which gives us 40. So he can file 40 reports in 8 hours. Any questions There. Okay, we're doing pretty good on time. Let's keep going. Number 5, solve the inequalities. Part A, 4x is less than or equal to negative 28. So similar to when we were solving equations, we want to get the variable alone. I need to get this x alone, which means I gotta get rid of the 4. To do so, we divide both sides of the inequality by 4. So I'm left with x is, oops, wrong color. I'm left with x is less than or equal to negative 28 divided by 4 is negative 7. And that's it. Part B. Negative 3x minus 9 is greater than 9. All right, again, our goal is to get x alone. So I'm first going to get rid of that minus 9 by adding 9 to both sides of the equation. That way those 9's cancel. I'm left with negative 3x is greater than 9 plus 9 is 18. So we're getting closer to getting x alone. Lastly, to get x alone, we divide both sides by negative 3. So those negative 3's cancel. So x is what? Less than. Be careful here. Notice the sign flipped. Why did the sign flip? We divided both sides by a negative number. Okay, so remember, anytime you multiply or divide both sides of the inequality by a negative number, you flip the sign. Notice on the previous question, we also divided both sides of the inequality, but we did not flip the sign because it wasn't by a negative number, right? 4 is a positive number, so the sign stayed the same. Whereas here, we're dividing by a negative number, so the sign flips. 18 divided by negative 3 is negative 6. Any questions on that one? Okay, we got one more inequality problem. Notice this time that we have y's on both sides of the inequality, and you want to get it to the same side. So in this instance, so remember when we solved equations and the variable was on both sides, did it matter what side you got it on? No. And technically, it doesn't matter what side you get it on here either. But my recommendation is to always get your variable to the left-hand side. Okay, move your variable over to the left-hand side. You don't have to, but that's my recommendation because then I find students are less likely to make an error in interpreting and whatnot when they do so. So that means I need to get rid of the y that's on the right. And I do so by adding 4y to both sides of the inequality. So that way those 4y's cancel. What are we left with? 2y plus 4y is 6y. Bring down the minus 5. Is greater than or equal to, bring down the 7. So we're getting closer to getting our y alone. Next, we can add 5 to both sides of the inequality, so that way the 5's cancel. We are left with 6y is greater than or equal to 12. And lastly, to get y alone, divide both sides by 6, so that way the 6's cancel. We're left with y is, tell me, does the sign flip or does it stay the same? Stays the same, good, because we're dividing both sides just by a positive 6. You only flip it if it's by a negative. 12 divided by 12 divided by 6 is 2. Any questions? No questions? All right, I think we have time for one more. Let's do one more. Number 6. The population of zombies in the Game of Thrones is changing exponentially. The function that models the population is P equals 100 times 1.25 to the power of T, where T is the number of months since the zombies first appeared, and P is the number of zombies. Part A. Is this exponential growth or decay, and why?
Growth.
So I'm hearing growth. Why is it growth?
Because it's
Greater
over
than
1.
one.
Because our base is greater than 1. Good. So this is exponential growth. Exponential growth because our base B equals, okay, look to your base. Remember, your base is right here, right? Our base is 1.25, which is greater than 1. That's what makes it exponential growth.
What if we just put something like 1.25 is greater than 1?
Yep, uh-huh.
Do I have to put B?
No.
Okay.
Part B. Describe the change in the population by stating the starting population and how the population is changing each month using a percent. Okay, so one thing at a time. First of all, what is the starting population? So looking at this equation, you should be able to say what the starting population was. What is it? 100. Good. Remember, the number in the front is always the initial value. It's always the starting value. So the initial zombie population was 100 zombies. Next, it also wants us to describe how the population is changing. Okay, so, and they are growing, right? We already determined they're growing, right? And they are growing at a rate of, and remember, in case you forget how to find the rate equals 1 minus B. Okay, so we're doing 1 minus, we said B, our base was 1.25, which is 0.25. And it does want a percent form. So they are growing at a rate of 25% per what? How often is it? Is it per day, per week, per year?
Month.
Per month. Any questions on part B? Okay, part C. Find the population of zombies at 1 month, 3 months, 5 months, and 7 months. Round, no decimals. Okay, so I'm going to make a little table here, I think, to help just keep my thoughts organized. So I'm going to do the month and then the population. I know it wanted 1, 3, 5, and 7 months. I'm going to do it off to the side. So for the population of 1 month, that'll be P equals, and we're just using the equation given. Where do I should have asked you, where do I plug into the 1? Am I plugging the 1 in for P or am I plugging in for T?
T.
For T, good. So P equals 100 times 1.25 to the power of 1. Plugging that into your calculator and rounding, we don't want any decimals, that would be 125. And we do it again. P equals 100 times 1.25 to the power of 3. Plug that into your calculators. Rounding, no decimals. You should be getting 195. Let's do it again. This time with 5 and for t. So P equals 100 times 1.25 to the power of 5. That is 305. And lastly, P equals 100 times 1.25 to the power of 7. That's giving me 477. Any questions on part C? So we're just plugging in the month values given individually into the equation. Okay, part D. Graph the ordered pairs, months and zombies. Okay, so we found our ordered pairs here. So let's graph them. And we're doing this by hand, so I know it's not going to be perfect, but we just do our best. Where we know that months is the x-axis. So, and we go as high as 7 months. So 1, 2, 3, 4, 5, 6, 7. And then we know the x-axis is the population. The highest we go is just under 500. So I'm going to count in increments of 100 up to 500. So 100, 200, 300, 400, and 500. And that is the zombie population. Okay, so even though month 0, we did not include it on our table, you guys should know at month 0 what the population was. What's the population at month 0? It's not 0. 100. That's our initial, right? We had set up here the initial zombie population was 100. So we're starting off with 100, okay? So starting off with 100, because we said that earlier. So that's here, okay? Initially, the zombie population was 100, so that's what you start with. I'm then going to include these values, pairing them together. So at 1 month, the population is 125. So that's like, again, I know this is hard, you're just doing it by hand, but it's like about here. At 3 months, it's 195, so it's just about at the 200. Oops, I put in the wrong spot. At 3 months, it was just under 200. At 5 months, it's just over 300. And then at 7 months, it was at 477, so about here. Again, I know visual estimates, but about like that. And then so it's curvy. I totally missed that point, but it's supposed to be curvy, connecting the points. As you can see, I'm struggling on here. Any questions there? Okay, I'm going to stop with this question. We'll pick up with the remaining questions in the MSC during the optional review session. And I want to emphasize again that the questions on this review should not be all of your studying. It's not enough. You need to be reviewing our lessons and your homework as well. Okay? All right, I'm going to stop.